Barometer is a device to measure the atmospheric pressure. Now, what is atmospheric pressure? If this is the earth is surrounded by a huge layer of atmosphere around it. So, roughly it extends above uh, 200 kilometer above Earth. So, this atmosphere or the layer of atmosphere is attracted towards the center of the Earth due to the gravitational pull. So, these gases will exert a pressure on the surface of the Earth. So, this is P naught, the atmospheric pressure. And as you go above the Earth's surface, obviously the atmospheric pressure will decrease, because then you have lesser weight of the atmosphere on top of you. So atmospheric pressure this decreases with height. By the way, P naught is the atmospheric pressure at the surface of the Earth, and its value is round about approximately 10 to the power 5 Newton per meter square, or 10 to the power 5 Pascal. So that's a huge pressure. Now, barometer is the device to measure the atmospheric pressure. Now, in a certain vessel, if mercury is kept and on top of it there is a glass tube, and the upper end of the glass tube is closed and this part is evacuated. That means this part is vacuum. Now in this vacuum, so due to this vacuum, what happens? On top of the mercury, what happened? Yeah. So on top of the mercury column, vacuum means there is no atmospheric pressure. While if you look at the mercury outside, there it is atmospheric pressure in this side. But due to vacuum, there is negligible pressure. So what happens actually in this so the open region, it is not exactly vacuum. There is some mercury vapor in that region, but that is very negligible pressure. However, now what we do? So as you know, so at this level, say we choose 2 points, one point B and the other point A. So A and B are in same horizontal level, are in same horizontal level inside mercury. So pressure at A is equal to pressure at B. Now mercury rises up to a level H above the free surface. So PA is pressure due to the weight of the mercury column. So that is H rho G. Now pressure at B is equal to atmospheric pressure P naught. Therefore, after equating you get H rho G is equal to P naught. Now we can substitute the values. So therefore H is equal to P naught by rho G. So H is equal to P naught. If you put here 10 to the power 5, and rho, density of mercury, is 13.6 times 10 to the power 3, and G you substitute 9.8, then you get here 0.76, or the height is 76 centimeter of mercury column. That means sometimes you say the atmospheric pressure is 76 centimeter of mercury column, and this is the meaning of that statement, that the atmospheric pressure is equal to the pressure exerted by 76 centimeter of mercury column. Now we will discuss about manometer. Manometer is a device to measure pressure of a gas in a closed vessel. So measures pressure of gas in a closed vessel, or say this is the vessel containing a gas. This is a gas vessel. It has gas. Pressure of the gas is P. Now manometer, by manometer, what you do, you make a small hole in this chamber, and this is an U tube. This is how it goes, and inside the U tube you have mercury. Generally, if you have mercury here, then due to high pressure, the gas will press the mercury column downward. That is it. So this is, this is mercury, and generally this is known as the manometric fluid. The fluid that is used for the manometer to function. Manometric fluid. And say the height, difference in the height happens to be H. So here, if you mark 2 points, say this is point A and the point B. See, A and B, obviously they are in the same horizontal level. So pressure at A is equal to pressure at B. Now, so due to open end, P0 atmospheric pressure will act from the top of this right column of the U tube. So PB is equal to P0, the absolute pressure, P0 plus H rho G. Now what is PA? Now PA, the pressure of gas inside the chamber, is P. Now due to height, variation of pressure in a gas is very negligible. So you can consider all throughout this the gas is having same pressure P. That means it has pressure P here also, pressure P here also. Due to height, because density of gas is very less, so change in pressure due to height is negligible. So we can regard this pressure PA to be P itself. So therefore now you equate. So P is equal to P0 plus H rho G. So this so actually the absolute pressure, so P is absolute pressure of gas. In the vessel, and so H rho G is the gauge pressure. So absolute pressure minus P0 is equal to H rho G. This is the gauge pressure of gas in the vessel. So condition of flotation, body floats if say either fully or partly submerged. Obviously W is equal to B, weight is equal to buoyancy, right? Now what is apparent weight of a body submerged in a liquid? So apparent weight of a body submerged in a liquid is weight minus buoyancy, because the measured weight is what the weighing machine will read. So suppose you have a weighing machine here, and while the body is submerged, the whole thing is submerged inside the liquid. So the forces that act on the body are the weight and the buoyant force, and there it goes the normal reaction. So the weighing machine, this reads the value of N as the weight. This is the apparent weight. So obviously this body is in equilibrium, so N is equal to W minus B. So apparent weight of a floating body is always 0. We will look at the line of action of the buoyant force and the weight. So on the floating body or whatever, maybe a submerged body. Now suppose this body is submerged. So it is partly submerged inside the liquid at rest. Now the weight of the body, obviously it acts through the center of gravity, W, and buoyancy or the buoyant force acts through center of buoyancy, CB. CB means center of buoyancy. So this is the line of action of the buoyancy force. So this center of buoyancy is actually the center of gravity of the displaced fluid. So center of gravity of the displaced fluid, you can guess it to be somewhere here, right? So this is CB and this is the buoyancy force. Now what happens when the body tilts? Suppose this is a liquid, and suppose you view a ship. So the ship looks like this. Okay. Now we are looking at the front view of the ship. So the front view of the ship will be like this. The hull of the ship is like this. Now presently when the ship is floating in water, then what is the center of buoyancy? That is easier to locate. Center of buoyancy is approximately here by guess. Say this is CB. Center of gravity means center of gravity or center of volume, you can say, for this displaced liquid. So I'll show you what is the displaced liquid. That means this part. Center of buoyancy is center of gravity of this shaded part, and the buoyant force acts upward, B. Now what about the center of gravity? Center of gravity of the ship depends on where the load of the ship is put. Suppose the load is put say on the top part, maximum, or say you guess somewhere center of gravity may be somewhere here, CG. So this acts downwards, W. Right. Now let's take a condition where this tilts. So the ship tilts a bit. This is the ship, front view of the ship, and weight acts through center of gravity, W, and center of buoyancy is somewhere here. So this is the buoyant force acting. See, despite weight being equal to buoyant force, still this is not a stable condition, because see, the couple or the torque will try to topple the ship. So that is unstable equilibrium. So for stable equilibrium, if the ship tilts a bit, obviously while moving on, the ship will tilt because of the waves in the sea or the river. So best way uh, for stability, best way to assure the stability of the ship is to bring the center of gravity as low as possible. So that weight acts through center of gravity and center of buoyancy on top, and maybe here, right, as it has tilted, center of buoyancy may shift here, but still, to be on the safe side, make the center of gravity of the ship as low as possible. So how you can do that? Load the cargo and all those things at the bottom part of the ship. This will ensure the stability. Got this point? This center of buoyancy, see, it is the center of gravity of the displaced part of the fluid. So the torque, main thing is the torque should be a restoring one, which will try to restore the ship to the equilibrium position. So let's take up this problem to explain the concept further. Uniform rod of length B capable of turning about its end, which is out of water, rests inclined to vertical. Its specific gravity is 5/9, that is density of the solid is 5/9 gram per cc. Find the length immersed in water. So let's draw it again. So that is a fixed point O, and at an angle theta we have to find the length immersed. So let the length immersed be L. Okay, now center of gravity is at the midpoint. So that is total length is B. So from O, distance of center of gravity CG is B/2, and through this the weight acts downwards. So the weight is equal to B length into alpha into, so let's calculate all this in CGA system, into 5/9 into G, because in CGA system this density of the solid of which the rod is made of is 5/9 gram per cc. Okay, and next about the submerged volume. So this is the liquid and the submerged volume inside the liquid is this. So buoyancy acts through the midpoint of this submerged volume, that is center of buoyancy here. So this way, this is the buoyant force. Now what is the buoyant force? Oh, what is alpha? So alpha is cross section of the rod. Okay, so buoyant force is L alpha. So as it is submerged in water, density is 1. So L alpha 1 into G. Now the distance of the center of buoyancy from the hinge at O is equal to B minus L/2. So now we calculate the torque from the hinge. So we cannot equate the forces here because there is a force in the hinge, so we can't equate weight and buoyancy in this case. So rather we'll do this torque balance. So net torque is equal to 0 about the hinge O. So the torque of weight is B alpha 5 by 9 G multiplied by B by 2 times sine theta is equal to torque due to buoyancy, because the clockwise torque is balanced by the counterclockwise torque. So L alpha G multiplied by B minus L by 2 times sine theta. Now this sine theta will cancel. So therefore, so these few steps of calculations, you get a quadratic equation in L, and after which you get two values of L. One is 5b by 3, which is greater than b, not possible. One is b by 3. So the answer is so L is equal to b by 3.